Welcome back, students. Today we're going to do our exam one review, okay? And then at the very end, I'll go through some exam protocols. Let me pull up the review. Okay, here we go. Okay, so Math 112, Unit 1 exam review. Okay, Jolene collected the ages of all students in her math class. She found the distribution to be skewed right. What does this mean? Okay, so if we have a distribution that is right skewed, means right tailed, means there's a bunch of data at the beginning, but not so much data at the end. So what this means is that, we're going to assume that the ages run chronologically. And so maybe we have like 20, 21, and then not so much, out at 30 or past 30. And if this is right tailed, it means that there's younger students more so than older students. So answer A is the correct answer here. There are a lot of younger students and fewer older students. Okay, number 2. A random sample of 35 students are selected and asked how many text messages they sent the last week. The results are recorded in a stem plot below. Use the stem plot to fill in the frequency table. Okay, so the frequency for 0 to 29. Okay, so this, if we were to, look at this, this is 1. Okay, this is 10. This is 23 and 25. Okay, interpreting the stem and leaf plot. Okay, oops. 23, 25. So how many are between 0 and 29? Well, there's 4 of them. There's these 4. Okay, what about between 30 and 59? Okay, so 30 and 59, we're just going to kind of add up the numbers here. Okay, so how many numbers are on the right side? Well, there's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. Okay, 16 values that have a stem of 3, 4, and 5. Okay, what about the next one here? 60 through 89. So these guys. So let's count those up. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Okay, and then the last ones here are going to be 1, 2, 3. So 3 of those. Okay, adding these up. Okay, that's going to give me the total amount of values here. So this is 4 and 16 is 20, 32, it looks like 35. Okay, total values. Okay, so we could have probably just done 35 from the problem too. So relative frequency, so this is going to be 4 out of 35. This is going to be 16 out of 35. This is going to be 12 out of 35. And this is going to be 3 out of 35. Okay, cumulative frequency. So this is where we add up the frequencies. This is going to be 4, and then 20, and then 32, and then 35. Okay, cumulative relative frequency, that's going to be 4 over 35, 20 over 35, and that will reduce to 4/7. Okay, 32 over 35, and 35 out of 35, which will reduce to 1. Okay, number 3, use the following summary statistics in your calculations. Determine if any outliers, we have the 5-number summary here, determine if any outliers exist, okay, in the data set using the 1.5 times IQR rule here. So first we have to find out, well, what's the IQR? What's the interquartile range? And that's Q3 minus Q1. So Q3 is 51. Okay, Q1 is 35. Okay, and that is equal to 16 when I subtract. So now I need to go, okay, what's 1.5 times 16? And that's 24. If I multiply that on calculator, 16 times 1.5 is 24. And so I know that to get an outlier, or the fences here, remember to get those fences on my box plot, okay, what are my fences? Well, they have to be 1.5 above Q3 and 1.5 IQRs below Q1. And so if I take Q1 minus 1.5 times the IQR, I'll get my lower fence. If I take Q3 and I add 1.5 times the IQR, I get my upper fence. Okay, so Q1 here was 35. So 35 minus that 24, 1.5 times the IQR is going to be 11. Okay. And then, so this fence was 11, the lower fence was 11. The upper fence, Q3 plus 1.5 times the IQR, that's going to be 51 plus 24, and that is going to be 75. So that's my upper fence. Now, are there any values here in my 5-number summary that are lower or than 11 and bigger than 75? Yes, there are. There's the minimum, which is 10, and the maximum, which is 79. So we know that there are at least 2 outliers. So at least 2 outliers, and that's the maximum of 79 and the minimum of 10. 79 is greater than 75, and 10 is less than 11. So at least 2 outliers there. Okay, let's flip the page. Number 4. Consider the following data points. Draw a box plot displaying any outliers. Okay. So here we're going to have to figure out what our IQR is. Okay, we're going to have to figure out what everything is, basically. Okay, so let's get our 5-number summary. The min, the Q1, the Q3, or sorry, the median, the Q3, and the max. Okay, let's figure out what these are. Okay, so the minimum is 1. The maximum is 81. Okay, the Q1 is going to be what? Let's find out how many values there are here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 values. Okay, so if I split this, in half, okay, then I get a lower half and an upper half. Okay, and so in the lower half, we have Q1, which is going to be the middle of our lower half, which is 33. That's Q1. The middle of the upper half is Q3. And how do I find my median? Well, it's just the average of these two. But if I take the average of 2 numbers that are the same, I get the same number. And so this is the median. The median is 35. Is the median, so that's 35. This is going to be 33, and this is going to be 51. Okay, so let's start constructing a box plot. Okay, so we know that we go from 1 to 80, so maybe go up by, I don't know, tens here. Okay, so start at 0, 10, 20, 30, 40, 50, 60, 70, 80. Okay, our minimum number is 1, but I don't know if that's an outlier yet or not. Yeah, our Q3 or our Q1 is at 33. So 33, I'll say is about there. So that's Q1. The median is at 35, so that's there. Okay, the Q3 is at 51. So that's there. Okay, so we have this as our box. Okay, but I don't know how far up my whiskers go yet until I calculate my fences. Okay, so let's find out what our IQR is. Okay, our IQR is 51 minus 33. So 51 minus 33 is 18. Okay, so the IQR is 18. 1 minus 33, which is 18. So 1.5 times that, 18 times 1.5, it's the same as what we did before. No, 16. Okay, 18 times 1.5. Is 27. So the IQR here is 27. So I'm going to take my low value of 33 and subtract off 27, which is going to be equal to, what is that, 6? Okay, and then I'm going to take my, so that's my lower fence. Okay, and were there any numbers that were lower than 1? Yeah, were lower than 6? Yes, it was 1. So that's so 1 is an outlier. Put a star above it just to say, hey, you know what, you're an outlier. Okay, and then what about 51 plus 27? That's 76. Were there any values that were above 76? And yes. I'm sorry, so that should be 78. With any values above 78. Okay, yes, and that's 81. So I'm going to star that guy. He's going to be an outlier. Okay, so where do my whiskers go? Well, my whiskers only go up to the value, the highest value that's not an outlier. So the highest value that's not an outlier here is 72. So if I draw a dot at 72, then my whisker goes out to 72. But that 81 is an outlier. So I'm gonna star it. Okay, what about the lowest value that's not an outlier? That's 9. So I'm gonna go to 9 here. Okay, draw my whisker. And then 1 is an outlier. So we put a star there for 1. Okay. So the lowest value that was inside my fence, my lower fence is 9. So I only go out to 9. Okay. And then my upper value that was inside my upper fence is 72. So we only go up to 72 for our whiskers. Okay, number 5. A university instructor created a website for her organic chemistry course. The students in her class were encouraged to use the website as an additional resource for the course. At the end of the semester, the instructor asked each student how many times he or she visited the website and recorded the counts. Okay. Based on the histogram, describe the distribution of the website. Well, it definitely looks like it's skewed left. Okay. So we'll say that it's left skewed. Okay, remember, what do we want? We want shape, center, and spread. Okay, shape, center, and spread. So for this, it's left skewed. Okay, that's the shape. The center, where would the center be? Where would the median be? Well, I would say that the median is probably around 13 or 14 here. Okay, so maybe the median I'll say 14. Okay, if we want to think about, where's the middle value? Okay, we don't have a lot of values over here. We got an outlier there. We don't have a lot of values over here. The majority of the values are 14 and 15. I'm going to say that the median is 14. Median is about, I'll put about 14. Okay, that's the center. And then the spread, we really don't know much about the spread except for the range here. So the range is 15 minus 1 or 14 as well. So the range is 14. Would the mean be higher or lower than the median? Okay, so this is skewed, right? Skewed data. Okay, so, and we have an outlier here. So here the mean would be lower than the median. Okay, would it be? So the mean would be lower than the median because of all the low outliers. Okay. The mean would be lower due to lower than the median, okay, because the data is skewed left and there are low value outliers. Okay, C, which would be more appropriate variation to use, standard deviation or IQR? Okay, well, it would be IQR since the data is skewed. Since the data is not symmetric, we would go with the IQR. Okay, and we also would go with the median if it was, for the mean, for the middle. Okay, because it's resistant to skewed data. Okay, number 6, use a box plot to help answer the following questions. Okay, overall grade in Math 83 versus Math 219. Compare the center and spread of the distribution of overall grades given in Math 83 versus Math 219. Okay, 83 classes, okay, seem to have a higher median. They have a higher center. Okay, so Math 83 has a higher center. Okay, but the 219 have a wider spread. Okay, the Math 219 has a wider spread of values. Okay, we can see that the values, the IQR is wider and the range is wider as well. There are no outliers here. Wider spread. Okay, approximately what percentage of students in Math 83 score below 60 and 80? So we can see that the lower 3 quartiles, okay, are between 60 and 80 for Math 83. And so, well, if that includes 3 quartiles, which is 3/4, that means that it's 75%. Approximately what percentage of Math 219 is above 85%? Okay, so that's this quartile, okay, which is only 1 quartile, which is 25%. The top quartile. Which class has a higher percentage of students passing with 70% or better? Okay, so 70% I'm going to call here. And so for Math 83, we have 50% passing, okay, which is not the case for the Math 219. So Math 83 has more passing? More 83 has more passing with 50% of the class. Okay. Okay, Jared has a mean on his quizzes with a mean of 74 on his quizzes with a standard deviation of 7. On his most recent quiz, he scored 65. Is this unusual compared to how he usually performs on his quizzes? So let's see. Let's do a z-score here. So z is equal to, remember it's x minus mu over standard deviation, sigma. So we're going to compare 65, his new score, to his mean, which is 74, over 7. Okay. So 65 minus 74 is what? Is that negative 9? Yeah, negative 9 over 7. Okay, so let's go to the calculator on this. So 64, negative 9 divided by 7. Okay, which is negative 1.28. So this is negative 1.2, I'll call it 1.29, which is 1.29 standard deviations below the mean. And remember, what was unusual? Well, it's unusual if it's below 2. Okay, it's only unusual if it is below 2 standard deviations. Okay, so it is not unusual. Okay, so not unusual there. Okay, let's move on to number 8. Number 8. Below represents the amounts of a random sample of employees reported they spent on dinner last night in dollars. Find the sample standard deviation. Interpret this standard deviation in context. Okay, of the problem. Okay, so let's go to our calculator on this one. Okay, remember this is a sample standard deviation. So let's go to stats. Let's edit our values here. Okay, so let's clear this. Okay, and so the values that I want to plug in here are 7, 12, 36, 50, and 50. Okay, so I'm going to hit stats key. I'm going to arrow over to calc, hit enter, 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 enter. And it tells me that what do we want? We want to interpret the standard deviation in context of the problem. So the sample standard deviation is S of X, that's 20.518. So 20.518. So the sample standard deviation is 20.518. Okay, and then what's the mean here? We need to interpret this in terms of the mean as well. So what was the mean? The mean was $31. Okay, so basically $31 plus or minus $20 on average. Okay, so this was $31. Okay, so to interpret this, we would say that on average, the employees spent about $20.52 away from the mean of $31. Okay, which pair is the best measure of central tendency and spread for the distribution below. Okay, so this is kind of skewed data, right? So this is right skewed. So what's the measure of central tendency here that we want to use? We want to use the median. And what's the spread? That's the IQR. Okay, so the median and the IQR for this one. Okay, for the next two problems, consider the following situation. Okay, management at a retail store is concerned about the possibility of drug use by people who work there. They decide to check on the extent of the problem by having a random sample of employees undergo a drug test. Several plans for choosing the sample are proposed. Name the sampling strategy in each. There are 4 employee classifications of approximately same number. Supervisors, full-time clerks, okay. Randomly select 10 people from each category. So this is a stratified sample. Stratified. Okay, so we take the same number from each category. It's a strata, okay, along each category. Employee has a 3-digit identification number. We randomly choose 40 numbers. So this is just a simple random sample. Okay. Okay, sample number 12. A sample of 120 men and 120 women are assigned at random to 2 treatments using the following method. Each man is assigned a number 0 to 120, and each woman is assigned a number 1 to 20 to 240. Software randomly selects 60 numbers between 1 and 120 and 60 numbers between to receive a pill with 200 milligrams of caffeine. Those not selected by the software are given a pill without caffeine. If the group that takes caffeine shows to have a higher heart rate on average, can we infer that caffeine can increase heart rate? Why or why not? Okay, yes. Okay, this meets all the criteria. Okay, all the criteria for a controlled experiment. We have a placebo. Okay, we have divided them into men and women. Experiment. Okay, it's a controlled experiment. Okay. Next one. Number 13. Because we have set 1, set 2, set 3, set 4. It says draw a dot plot for each of these. Okay. So they're all kind of, the first 3 are all kind of going from 9 to 13. So 9, 10, 11, 12, 13, 9, 10, 11, 12, 13, 9, 10, 11, 12, 13. Okay, the other ones go from 32 to 36. The last one, 32, 33, 34, 35, 36. Okay, so the first one, we've got 9, 10, 11, 12, and 13. One each. 1 dot each. Okay. The next one we have 9, 11, 11, 11, and 13. Okay. The next one we have 2 9s, 1 11, and 2 13s. Okay. The next one we have 32 through 36, all the same. Okay. Without performing any calculations, which data set has the largest standard deviation? Well, it's going to be this one here, where I have the majority of the data on the far right and far left. Okay, so that's going to be the largest. Okay, the largest standard deviation. Okay, and then which one would have the smallest standard deviation? That would be this one that has the majority of the data in the middle. Okay, so this would have the smallest. Okay. Okay, number 14. Okay, Jesse scored a plus 12 while golfing and 18 points while playing basketball. The statistics for teammates for each score are below. And which score did Jesse do better when compared to her teammates? In golf, the lower your score, the better. Okay. Okay, so let's calculate the z-scores here. Okay, z-score for golf, okay, is going to be Jesse's score is 12, so this is going to be 12 minus 14.2, which is the mean all over. The standard deviation is 3.2, so that's the z-score for golf. So let's get that guy. 12 minus, oops, 12 minus 14.2, 9.8, divided by 3.2 is 3, sorry, what I did here. 12, it should be 12 minus 14.2. That's not going to, that doesn't make sense. Okay, 12 minus 14.2 is equal to, there we go, negative 2.2. Divide by 3.2 is negative 0.6875. Okay, or we could just say negative 0.69. Okay, so the z for basketball, the z-score for basketball, that's going to be her score, which is 18 points minus 12.5 over the standard deviation of 4.1. Let's calculate that z-score. 18 minus 12.5. Hit enter. 5.5 divided by 4.1 is 1.34. Okay, 1.34. Okay, so we want to know, okay, relative to, we standardize these scores, right? So in golf, she got less than one standard deviation below the mean. So think about all the mean being at 0. She got negative 0.69 standard deviations below. Okay, so and that's a better score than the mean of her teammates, because in golf a lower score is better. Okay, so she got a 12 compared to a 14. Okay, with the standard deviation, so 3.2, so negative 0.9. However, for basketball, the higher the score, the better. And the standard deviation that the z-score she got here was 1.34 standard deviations above the mean. So she was better in basketball than she was in golf. Okay, so we're going to go with basketball here, because she was further away from her teammates. Okay, what does the z-score in basketball represent in context of the problem? Well, it means that she, or that I should just say Jesse, because we don't know if that's a male, female, or other. Okay, Jesse means that Jesse scored 1.34 standard deviations above her teammates average. Okay. Okay. 15. 1,600 young students are asked the following question. Of the following, which subject do you enjoy most? Math, history, or math, English, or history? How many students enjoy math the most? Okay, so we just need to know, okay, math is 40%, so we just need to do 40% of 1,600. Okay, and so pretty easy calculation. 0.40 times 1,600 is 640 students. Okay. Okay, 16 is a repeat, so we can just cross that out. Okay. Number 17. Okay, a school is participating in a canned food drive. The following data represents the number of cans collected by a sample of 12 classrooms. Find the mean, median, mode, and standard deviation, IQR, and range for the sample data found in this scenario. You may use technology. Okay, cool. So I did the calculator last time. Maybe we'll go to StatCrunch on this one. Okay, so let's go to StatCrunch here on this one. Okay, and sign in. Okay, sign in. Can you bring me up my StatCrunch, please? Okay, open StatCrunch. Let's put in these values here. Okay, so we want 5, 5, 10, 16, 19, 26, 40, 49, 60, 64, 79, 98, and 98. Let me just double check to make sure that I didn't mess up. 5, 10, 16, 19, 26, 40, 49, 60, 64, 79, 98, and 98. Okay. And now I want to just go to stats. Okay, and then go summary stats and then columns. Okay, so what are they asking me for? They're asking me to find the mean. Okay, so the mean. Okay, what else did we want? We want the median. Okay, so that's okay, the median. Do I have a median? Yep, the median. Oops. I gotta hold down the control key. I forgot about that. Oops. Okay, so median, okay. And then we want the mode. Okay, I think that's all the way down at the bottom, the mode. And then we want the standard deviation. Okay, and then we want the IQR and the range. I don't know if it'll do the IQR. I think we have to, oh, we'll do the IQR. Okay, so let me get rid of this one. Okay, and then let me put it back in. So it's at the bottom. Okay, so mean, median, mode, standard deviation, IQR, and the range. Okay, and then I'm going to hit compute. Must, so, oh, select the columns. Yes. Compute. Boom. Okay. So the mean is 47. The median is 44.5. The mode is 98. The standard deviation is 33.1. The IQR is 54, and the range is 93. Okay, pretty cool. Okay, so let me put that in here. Okay, so this was 47. The median is 44.5. The mode was 98. The standard deviation was 33.1. The IQR was 54, and the range was 93. Okay. Okay, number 18, college president is interested in estimating the proportion of students who drive to school each day in order to plan for a future parking structure. To make this estimation, she randomly selects 250 students and asks them if they drive to school. Okay, identify the population of the study. This is students at a college, right? So this would be students at a college, okay, at a specific college. Okay, what is the parameter of interest? Okay, the parameter of interest is how many students commute, or the commuting students. Commuting students. Okay, identify the sample. The sample is the 250 students that were randomly selected. Randomly selected 250 students. And what is the statistic in the study? Okay. We want to know the proportion of students who drive to school. So the proportion of students who drive to school. That's what we're looking for. And this would really be the proportion of students out of the 250. Okay, we would say that, you know, there's a certain number of students X out of 250 that drive to school, and that would be our statistic. This would be our sample proportion. Okay, that's our sample portion. Okay, what is a distribution? Okay, a distribution is all possible data values and their frequencies. Okay. For each type of graph, state whether it is more appropriate for categorical or quantitative data. Okay, categorical or quantitative data. Okay, for a pie chart. Okay, pie chart. Well, usually a pie chart is categories. Okay, it's categories. So that's categorical. Okay, a dot plot. A dot plot. That's usually numerical data. Okay, or quantitative. Okay, histogram is quantitative. We only use histograms for quantitative. Okay, a box plot. A box plot is quantitative data. Okay, a bar chart is different than a histogram in that it's categories. Okay, it's like green or blue or red. Okay, bar chart is categories. And a Pareto chart is just a bar chart, but it's just a bar chart that starts high and goes low. Okay, it's an ordered bar chart, so that's a categorical. Okay, number 21. School IT administrator was interested in seeing how educated the staff is in identifying suspicious emails. During January of 2016, she decided to conduct a study by collecting data. She divided the staff into the following groups: teachers, office personnel, administrators, other staff. The IT administrator then randomly selected 25 employees from each group. So this is a stratified selection. 25 employees from each group, and sent a suspicious email to the suspicious link. She then collected the following information: whether or not the person clicked the suspicious link, whether or not the person reported the suspicious email to IT, the number of emails the person received in the month of January, the age of the employee, and how many years they have been working at the school. Okay, for each variable below, listed above, determine which type is categorical and which is quantitative. So whether a person clicked the link or not, that's categorical. Okay, did you or did you not? Whether a person reported it, did you report or did you not report? Okay, that's categorical. Number of emails. This is the number of emails, okay, person received each month. And I'm going to go quantitative on this, although there you can make an argue for categorical because you can only have whole numbers. Okay, you can't have half an email. But I'm going to go quantitative. Quantitative with a caveat that this is just integers. Okay, you can only have whole numbers. Okay. Maybe not even integers, it's whole numbers. Okay, the age of the employee, I'm going to say that's quantitative. Okay, that also is going to be whole numbers. And how many years they've been working at the school, that's also quantitative. Okay, or numerical. What type of sampling method was used to collect the data? Oh, I already said that. That's stratified. Okay, stratified data. Okay, so that concludes the